Have you ever been looking at a computer on Amazon or Best Buy and just didn't know what to get, or taken someone's advice and bought a system that you weren't happy with? Well, my name's John Kelso, and I've been building computers since I was 16. And today, I'm going to teach you how to part out a system on PCPartPicker.com, and also gives you some advice on picking specifications for systems both custom-made and pre-built. To do this is very simple. There's a website called PCPartPicker.com, which will allow you to fully spec out a system with everything that you would need and provide prices for all of it along the way. All you need is a computer with access to the internet, and you're all set. The first thing that you must consider when picking out parts is your CPU and your GPU. These are the components that have the most effect on the computer experience. They are, effectively, the brains of the computer, the parts that do the actual computing. And as such, it's entirely reasonable to spend most of your budget on making those components as good as possible, without compromising on other aspects of the system. Now, when choosing your CPU, you'll be faced with a dilemma. Do I go Intel, or do I go AMD? Those are the two main microprocessor companies. As of right now, provided that you can get it at MSRP, which is no small feat, the AMD 5000 series of CPUs offer extreme amounts of value for the money, according to a Tom's Hardware review, with the Ryzen 5 5600X beating or meeting the Core i9 9900K in just about every application. However, should you need to save some money for a better graphics card, then the Ryzen 5 3600 is still one of the best CPUs for the money. It's worth noting that in laptops your options are far more limited, and Intel is much more competitive than AMD when it comes to mobile hardware. When considering a GPU, the decision is far more dependent on what you want to use it for. Most CPUs include graphics processing on the chip itself, so if all you want to use the computer for is browsing the web and using Word documents, you'll probably want to put that excess money into your CPU so that you have to replace it less often with something newer. However, if you are doing graphically intensive tasks such as 3D rendering, intensive CAD work, or video editing, then you'll probably want to get a GPU on par with your CPU to cut down on rendering times. In pairing with a 5600X, I chose an RTX 2060 because it's a powerful GPU which can handle heavy workloads according to a PC Games Network review without taking a huge bite out of your budget. If you wanted to, you could go up to a 2070 or even a 2080 class GPU without having to upgrade your CPU. But if you want to have a more balanced system, a Ryzen 7 5800X class of CPU would pair better with those larger scale kinds of GPUs. Next, you should choose your motherboard, which should be a little simpler than the previous decision. The big thing is to make sure that the board contains the correct socket for your CPU. Different CPUs will have different pin or pad mappings to different sockets on motherboards, and if you buy the wrong motherboard, the odds are that it will not work in your socket, and you will have a CPU and a motherboard, both of which will not work with each other. So, in PC Part Picker, it will only show motherboards with a compatible socket, which makes things easier for you. But there's still stuff in that section that can still trip you up. For example, if you choose a B450 or X470 board, it will still work with your CPU. It's the same socket. But because those are last generation hardware, it will not be compatible out of the box. The motherboard software will have to be updated in order to recognize it, which proves a problem if you don't have one of those and you're building a brand new computer. As such, I've chosen in our build a more modern B550 board, which should support our CPU straight out of the box. And there isn't much else special about it, but it provides adequate amounts of fan headers and USB ports to make it worth the $60-ish that you pay for it. Overpaying for a motherboard is one of the worst things that you can do in a computer. To a certain degree, the features are good enough because it won't affect performance. Memory is also a simple choice, as anything less than 8 gigabytes in 2020 is not great for the amount of RAM that certain programs take. Chrome. So 16 gigabytes is ideal. As far as memory speed goes, it depends on your CPU. Intel CPUs will perform pretty much the same regardless of memory speed, but Ryzen on AMD loves fast memory, and going from a 2400 MHz kit to a 3600 MHz kit can net you as much as a 15 to 20% increase in performance. That's a big deal. So I went for a 16 gigabyte 3600 MHz kit because 3600 is generally agreed that it's the sweet spot in terms of speed for Ryzen. Next up is storage, and there are two types, solid-state storage and mechanical storage. Solid-state storage is a more recent storage technology which allows for far faster transfer and download of files, and therefore cuts down on load and boot times significantly should you put your OS on an SSD. Mechanical hard drives, comparatively, are ancient. They've been around about as long as the format itself, and they are very, very slow. But they also offer much more capacity per dollar. A 1 terabyte mechanical hard drive will often cost about the same as a 240 to 300 gigabyte SSD. So generally speaking, my recommendation is to have an SSD for your boot drive, the drive that you install Windows on, and a larger mechanical hard drive to put your mass storage on, your files, your important things for long term, stuff that you don't access all of the time. When you do it like this, you'll end up with a machine that has a lot of storage, but also feels snappy and responsive all of the time. Almost done now. Next, we have the power supply. The power supply takes the AC power from your wall and converts it into DC power for use with your components, and is, as such, one of the most important parts of your computer, given that everything else in your computer will use the power that the power supply provides. It's a common, unfortunate mistake for first-time builders and for a lot of OEM manufacturers to cheap out on your power supply and have it fail spectacularly a couple months later and ruin your motherboard and possibly your CPU. The 80+ certification that you will see when you look at power supplies in PCPartPicker refers to a certification that power supplies can get that measures their reliability and their efficiency. That being said, a higher 80+ certification is generally better. The scale goes 80+, 80+ bronze, 80+ gold, 80+ platinum, and then 80+ titanium. The higher you can go, the better, but an 80+ certification at all will make it far better than anything that doesn't. Given our budget, I decided to go with a 650 watt 80+ bronze unit. But if you have the money, an 80+ gold power supply is great and will last you a very, very long time, especially since a lot of these things are put under extended warranty. The amount of watts that you need varies per system, and there are calculators online that will show you how much power your power supply will need to support it, but generally speaking, anything greater than 650 watts for mid-tier systems will do you just fine. And finally, we have the case. Arguably the easiest part to pick, because it depends a lot on your aesthetics and what you want to see in your build. But there are important things that you need to keep in mind about your case, and it's a common mistake to get a case that doesn't meet some of these requirements. Computer components, when they're running, generate a lot of heat, and this is by design. You're pushing power through silicon in order to get calculations out of it. The problem is that if you push a component too hard and get it too hot without any sort of restrictions, it will actually burn out the component and make it not work anymore. Modern processors have gotten around this problem by having on-die monitors that will constantly check the temperature, and if they see that it's about to get too hot, they will throttle the speeds back down in order to reduce the heat output. This, when you're using it, will feel like your CPU just took a huge hit and will be chugging due to this process that we call in the PC space thermal throttling. So you want to be able to have a case that will provide adequate airflow to move air across your included CPU fan and across your GPU fan in order to keep those dies cool in order to get the most performance out of them all the time. So I went with the Fractal Design Focus G because of its excellent airflow and reasonably attractive exterior, along with plenty of space on the inside for cable management, according to Tech Power Up. And that's pretty much it. You now have a very good PC build for around $1,000, which will do most of what you want it to do. And even if you aren't going to build it yourself and you're going to buy from a manufacturer of some kind, you can still take the advice that I gave regarding computers and apply it to those systems. A lot of the times, manufacturers will cram an i7 and a top-tier motherboard into a system and then throw an entry-level graphics card into it and sell it to people who don't know any better. Being a smarter shopper, knowing what to look for, and knowing what these things do will ensure that you spend your money smartly and less often while getting everything that you need to get your high-intensive work done. Thank you.
By the way, my nose was like plugged out through the entire time I was recording this, so I apologize if that was like not great. So, yeah.